Hi everyone, in this video I'm going to discuss some more methods that are available with the algorithm header file. So let's see what more operations we can do. So one such method is called rotate. Okay, so if you want to rotate some container such as array or a vector, you can just give how do you want to rotate that container. Okay, for example, if I say I have an array like this. Let's say this is 10, 20, 30, 40, 50, and I want to rotate this array from the middle index, let's say. So what I can say, array, then I can say okay, array plus 2 and array plus n. Okay, so start, middle and the end I have to give. So n is given by size of array upon size of int. So if I just rotate this array, and I can use a for loop to print the elements of the array. So I can just see out ARR of I. So let's see what we can get. So you can see we get a rotated version of the array, and clearly in this version of the array, you're just rotating the elements like this. So you're getting 30, 40, 50 followed by 10 and 20. So you get a rotated array. This is a rotated array. Similarly, you can also apply these functions, searching function, sorting function, on vector also. For example, instead of having an array, if you have a vector, okay, so let me give you another example. You can also apply the same on a vector. Okay, so let me create a vector of integers v, and let me initialize with this array. Okay, and I can say for int I equals to 0, I less than v dot size, that is 5, I plus plus. Let me do c out v of I. Let's first see how do you create a vector. Okay, so a vector is nothing but it's a dynamic array. Okay, yeah, we need to include the vector file. Okay, so we have created and initialized a vector, and these are the elements in the vector. Maybe if you want to rotate this vector now, you can call the rotate function. The starting point of the vector is given by v dot begin. Middle point, let's say you want to rotate after the third index, so you can say v dot begin plus 3. That is the iterator to the third index of the vector, and you can give v dot end, that is the ending point of the vector. Okay, and now let's see. Okay, so you can see you are able to rotate the vector like this. So you get 40, 50 followed by 10, 20 and 30. You can also have another method that is called next permutation. Okay, so suppose if you want to rearrange the elements of the vector or an array, so in order to generate the next lexicographically bigger number, so what we can say, okay, give us the next permutation. So this method is also available in okay, v dot begin to v dot end. Okay, so it is going to rearrange the elements of the vector, and we will get something. So let's see what we are going to get. And instead of iterating on the vector like this, we can also use for each loop. I can say for int x, for some element x that lies in the vector v, see out the value of x. So let us see what is the next number that is generated by this method next permutation. Okay, Okay, spelling mistake. This is permutation. Okay. Okay, let me just put a handle here. You can use these same methods with the array also. The only thing is you have to give the starting and the ending part of the array. Okay, so this is the output of the next permutation. Maybe I should show you with a simpler example. Suppose if I do not call the rotate method, and let's say the next element is 1 2 3. Okay, so you want to generate a number that is just bigger than 1 2 3. Okay, that should be 2 1 3. So let's see if we get the output. Oh, sorry, 1 2 3 followed by 1 3 2. This is the next number 1 3 2. And if I generate the next permutation again, then I will get 2 3 1. Okay, so maybe let's call this once more, and this time it will be 2 3 1. Okay, 2 1 3, sorry, 2 1 3. This is the next permutation that I can make by rearranging digits of this particular number. Okay, so these were some more methods that are available in the algorithm header file, and I hope you would have understood these.